Okay, I think we're ready.
All right. I just want to make one point about the book, When Science Goes Wrong. I love science. I've dedicated my life to it. And the whole point is that we love it even though it's not perfect. Just as we should be able to love people without them being perfect. And maybe even our enemies. So that's kind of going a little farther than I might want to go. Hello, this will come up. Yes. They've asked me to give 2 talks. The one tomorrow will be a little more talky in data and facts. What I want to do today is set the sitting of the universe we're in and the creator who made that universe. If we can kill the lights, it's mostly going to be pretty pictures with a few nice things.
You don't have to sit there. You can sit.
Yeah, give me. Go sit in the front seat. We can tell we're mostly Catholics here. Nobody's sitting in the front row. This is a picture, by the way, taken at the headquarters of the Vatican Observatory in Castel Gandolfo. I start with one of my favorite quotes from Chesterton. The earth is so very large, and the cosmos is so very small. It's about the smallest hole that a man can hide his head in. Well, he's a master of paradox, but in the paradox, he's trying to tell us something important. If Chesterton is too modern for you, we can go to the Psalms. This is one that every retreatant will probably recognize. It's one that comes up over and over again. O Lord, you've searched me and known me. You know when I sit down and when I rise up. You discern my thoughts from far away. You search out my path and my lying down and are acquainted with all my ways. Even before a word is on my tongue, O Lord, you know it completely. You hem me in, behind and before, and you lay your hand upon me.
Our last storyteller is Steve Collins, and Steve is the altitude control manager on NER. Actually, until this morning, I didn't have any idea what Steve was going to talk about, and when he told me, the difference between abstract and reality for him, I think you're going to find his story very, very interesting.
Thank you, Farouz. I'm actually just one of the many ACS engineers, kind of our bosses, the Elsimer team. And I wanted to tell you a story today about an event that happened a few weeks after the 2 landings. I'm an attitude control system engineer. I'm responsible for the gyros and the thrusters and the software that keeps the spacecraft or the rover pointed in the right direction. And as such, I live in this world of numbers. And sometimes it's hard to go from those numbers to the picture of what the spacecraft is doing. But that's kind of the job, is to figure out from the numbers, what direction is the spacecraft pointed today? So a few weeks after the landings, we were kind of in a groove at that point. We were living on Mars time, and so we were coming in at weird hours and not sleeping very well. And so it was the middle of the night, and I was in the control room. I was just coming off shift, and somebody, one of the other engineers, came by the console and kind of just, tapped me on the shoulder and said, "Go up to the 6th floor and check out the pictures." And then, he kind of went away, and it was kind of like it was a secret, or something special. And so I went up once I got off shift, I went up to the 6th floor to the UN conference center. That's what a lot of you know, the room I'm talking about. It's this large conference room where the science working group argues about who's going to do what with the rover the next day. And it has a big U-shaped table and microphones at all of the chairs, and it looks like the UN Conference Center. One of the things that they have in there is this high-resolution projection TV that's goes onto a screen 15 feet wide. And so I go in there, and the place is dark. It only gets used a few hours a day when the science team is making all these critical decisions about the rover planning. But so I go in there, and it's dark, and it's quiet, and there's a picture up on this big high-resolution screen, and you can't really make it out. And you can't really make it out because it's in 3D. And it's in the fancy kind of 3D, not the red-green glasses kind, but the kind that takes a set of special electronic glasses, and when you put them on, you can see the picture in color, in the actual natural color, but it's in 3D. And so I go in there and I step to the center of the room in the middle of this big U-shaped table, and there's a pair of glasses there on the table, and I put them on, and I'm standing on the surface of Mars. You can roll the clip that we have of this. And what I'm looking at is a color, high-resolution panorama of the Spirit landing site. And it's in 3D. And off in one corner I can see Sleepy Hollow, which is a sand trap that we decided we wanted to be careful and not drive into. And the thing slowly pans around, and as it pans around, you can see where the airbags have been, drawn back up and left scrape marks in the soil. And then we pan around a little bit farther, and off in the distance, there's a line of mountains you can see, and as it goes farther, you can see the whole expanse of the Columbia Hills out in the distance. And it's changed from being a set of numbers, on these telemetry screens to being a place. It's a place. And I'm thinking, I wonder if we could drive the rover all the way over to the Columbia Hills. Could we possibly do that? I sat there in the dark by myself for maybe 20 minutes and just, let this panorama scroll by and, thought about, holy cow, look at what we've done. It's a place. That's the view that an astronaut is going to see when they step out onto the surface of Mars for the first time. So I went back downstairs to the MSA and tapped my buddy Tony, who had just replaced me on shift, and I told him, when you get a chance, when you have a chance for a break, go up to the 6th floor and check out the pictures.
Somebody brought up the topic of narrative. Science is a narrative. Science is a story. It's a poem that we tell ourselves that tries to write poetically. The path of a falling object is like the solution to this mathematical equation. I forget, is that simile or metaphor when you use the word like? Simile. Steve, who you saw giving that talk, is an old friend of mine. He's an engineer at JPL. He's been involved in almost all the missions. And he has, of course, a master's degree in engineering, in theater engineering. He actually is a trained storyteller, as I think you could tell from the way he told that story. And his wife is the costume mistress for the Los Angeles Opera Company. He knows how to fix things on the fly, and if you know where that phrase comes from in theater, you'll appreciate what it means. But the bigger point he's making is the leap we must make from seeing things in the sky as pictures on our phone and thinking of them rather as places. That's a place. That's a place where we've left our mark. It's got the same kind of geology that we're used to on Earth, strata in the rocks, wind-blown sand dunes, same physics works. You could imagine walking around there. It's got air, not very much, but suspended in the air is dust as fine as flour of rust, so the sky is pink. Most of these are from the rovers of about 20 years ago that landed in flat areas, because that was where it would be safe. They were designed to last 90 days, and they lasted more than 10 years, because they figured out a way of having the Martian winds blow the dust off of the solar panels that you see here, so that they could continue to power the rover. But the later ones landed near the mountains. Got to be a little more adventurous. And if you're saying to yourself, that looks like a dried up riverbed, you're not the first one to think that. There's no liquid water on the surface now. Even the orbiters are able to get aerial views that look very different and very strange, and yet somehow familiar as well. Why would you have a square crater? Well, I can go into explanations that people have come up with, but forget that. Notice the streaks coming from about halfway down that seem to end up in a puddle. That's not water. That's dust that has been carried there by some kind of fluid, possibly water. But the pressure on the air is so thin that water would start evaporating as soon as it came out of the surface. Yet it might be liquid deep enough below the surface where there's pressure and heat that you don't have on the surface. And when you have a cut that the water can come out, maybe that's what we're seeing. But in any event, it's a place. You could walk around there. You could imagine walking around there. Someday people are going to walk around there. And it's got a sunrise and a sunset. We worry, and I think, legitimately about what would happen if we introduced Earth bacteria into Mars by accident. Would it be able to survive long enough that later on we'd discover that same bacteria and we wouldn't know if it was contamination or not? But it could have gone the other way. The meteorites that I study have cracks in them about the same size as microbes, and we have some that have been launched off the surface of Mars, traveled through space a few million years, and then landed on Earth. How do we know that life didn't start on Mars and ended up here? In fact, Mars spins on its axis slightly slower than Earth. Where a day on Earth takes 24 hours, on Mars it takes 24 hours and 39 minutes. Don't you really wish you had an extra 39 minutes every morning? Maybe we really are Martians, hearkening back to some ancestral memory. But the other thing about sunsets on Mars is that they're beautiful just like they are here. Be praised, my Lord, the ancient Italian is Laudato Si, be praised. Be praised, my Lord, through all your creatures, especially my Lord, brother, sun, who brings the day, and you give light through him, and he is beautiful and radiant in all his splendor of you most high. He bears the likeness. So wrote St. Francis, the 1400s, about a place very different from Mars, and yet it applies to Mars. Such knowledge is too wonderful for me. It's so high I cannot attain it. Where can I go from your spirit? Where can I flee from your presence? If I ascend to heaven, you're there. If I make my bed in Sheol, you are there. If I take the wings of the morning and settle at the farthest limits of the sea, even there your hand shall lead me, and your right hand shall hold me fast. When I first joined the Vatican Observatory, they sent me immediately to Rome, where I spent the summer. And then I went to Tucson by way of a Peace Corps reunion in Colorado, and then the train across the mountains, ending up in San Francisco, the University of San Francisco, where I did my retreat. And the retreat director gave me this psalm, and I thought, here I am, at the ends of the sea, as far away from the center of the world as you can get, and God's still there. And then eventually I wound up in Antarctica, and God was still there. The Earth isn't the only place, and certainly the moon is a place that we can praise my Lord through Sister Moon, that we have visited a number of times. This is an image that many of you may not have seen. It's from the North Pole. I think it's the North Pole. I have to look at the map. That's the Earth with the direction that we're used to. Or no, wait a minute. I think that's Australia. Yeah, it's upside down. This is the South Pole. I should have turned the picture upside down. No. It was taken by a Japanese spacecraft that orbited the moon around its poles. But the moon is a place where we actually have walked around. I know that guy. Harrison Schmitt. We've been on panels together. My very first, close to my first book as a Jesuit, Brother Astronomer, I went on book tour. And I showed up in a wonderful independent bookstore in Albuquerque, and Harrison Schmitt showed up at my book launch. And all of his friends were impressed that he knew the Pope's astronomer. But it's not fake. He's there. I've worked with the rocks from the moon. They are not rocks from Earth. They're different. It's a place. That's Buzz Aldrin. Many of you may know that when he went to the moon, he had 15 minutes of private time where he pulled out a chalice and a vial of consecrated wine, had a communion service. Of course, Presbyterian, it wasn't the real thing, but still. We'll forgive him. The Presbyterian Church on NASA Road 1 has the chalice, and in its stained glass it has a thin section of a meteorite, because a number of the scientists at the Johnson Space Center were also members of that congregation. I mentioned I went to Antarctica. That was out the front of a C-130 airplane, flying us there from Christchurch on our way to McMurdo. Everybody had a chance to look out the front window. We sort of walked up and took a peek and went back, because the C-130s are designed to carry paratroopers. So number one, you don't have windows. Number two, the seats are designed to have a parachute between you and the seat, which we didn't have. Number three, the food that they gave us was in a paper sack, and it included pudding, but they forgot to give us spoons. Last time I'm going to go on that airliner. Unpressurized, so at a low altitude, very, very slow, and the bathrooms were a hole in the side of the airplane. I really respect our soldiers. And that's where we landed, on an ice floe in Antarctica, and where I spent 6 weeks of my life living in a tent like that. These are all my pictures. Where we went across the ice looking for meteorites, as close as I would ever have experienced what it was like to be on another planet. This panorama picture I took at midnight, facing south. That's the sun peering over the South Pole. We were at about 80 degrees, so 76 to 80, something like that. I never got actually to the pole. Most of the time we would get in skidoos and go across the blue ice looking for meteorites, but it snowed one day, which it normally doesn't. This is a desert. And then for the next 12 days, the wind blew the snow off the ice, after which we were able to go out and look for meteorites again. Meteorites, they land everywhere, but when they land here in Indiana, they get wet and they rust and they fall apart in a few years. When they land in Antarctica, they stay frozen forever. When they land in Kentucky, they look like rocks, and Kentucky is full of rocks. When they land in Antarctica, they're black, the ice is white. It's real easy to find them. And the ice flows in such a way that it tends to concentrate the meteorites at the edges of mountains. Be praised, my Lord, through brothers wind and air, and clouds and storm, and all the weather, through which you give your creatures sustenance. Remember that if it rains on Monday. And there we are going back and forth. That is frozen water. That's not a lake. It's got hills going up and down, and one of our guys brought ice skates. Have you ever thought of ice skating uphill? One of the places we went had these shelves, this ridge above the rest of the plateau. And that snow you see is not just a little bit of snow on the ice, it's a crevasse. If you step into the snow, you fall through. Don't do that. Also, the pictures are this dramatic silhouette, not because I'm a great photographer, but because it's so bright with all the ice that my light meter kept saying, "Oh no, make it darker," until all of the pictures actually were underexposed. Whenever we found a meteorite, we'd chuck a hole and put a little flag there so that we could measure the position and see if there was any pattern and where the meteorites could be found. As far as I know, they've never found any pattern, but you had to take the data to find out. More to the point, it's beginning to get cloudy. Clouds are white, the ground is white. When it's cloudy, there are no shadows. You can barely see where you're walking. That's what a whiteout is. It's not that it's, snow blinding you. It's that you can't see shadows and everything is white and you don't even know which way is up. You get dizzy, you fall over on yourself. And that's the location of one of the permanent bases. The South Pole and McMurdo are the two permanent bases. And that's me. I know it's me because I was the only one with the red gaiters. It's basically, we figured we should actually have coats of arms that we would paint on our shields, like the knights did. If you were in armor, nobody could tell who you were except from the coat of arms and your shield. But the person who took that picture is my good friend Sarah Russell, who's a meteoriticist at the Natural History Museum. There were 6 of us. There was the guy who has been going to either Alaska or the South Pole as the safety officer. He's basically a mountaineer, and he's been doing that. He finally retired at 75. And the fellow in charge of the program, a fellow named Ralph Harvey, who was at his Case Western in Cincinnati, in Cleveland. An engineer from JPL, Renee Martinez, and myself. And then 2 women. So there were 3 tents, 2 people in each tent. Sarah was one of them. Sarah and I became best of friends. I'm the godfather to her daughter. And the other woman was, well, don't want to put it this way. She was kind of a giggly sorority girl kind of person. And she'd gone to Arizona State rather than Arizona, which is, typical sorority place. But she did take a couple of courses in chemistry in a summer program at the Lunar and Planetary Institute. And by the time she had joined us, she had just gotten her doctorate from Caltech. And just won the first near prize for students in meteoritics. And she was still, a school would fly overhead, these big, ugly seabird, and they would go, "Cock," and she would go, "Cock," back at them at the top of her voice. And that was so much fun that she kept doing it when we got back to New Zealand and was, walking down the streets of Christchurch going, "Cock," really loud. And just was kind of goofy. Whatever happened to her? Well, she, until recently, her last job was at Worcester Polytechnic Institute, where she was president of the university. She's not there anymore. She's now the director of the Jet Propulsion Laboratory. I don't think she makes school noises anymore, but she still has that sense of fun. Laurie Lesher, fabulous person. Antarctica is not the only place that reminds you of what the rest of the worlds can look like that you can also see on Earth. This is, one of those, I glued together a bunch of pictures for Meteor Crater. It's the same guy over and over and over again, walking in front of my picture. 50,000 years ago, a 50,000-ton chunk of iron, I think I'm making up the 50s, but that's, good to within a factor or 2. The chunk of iron hit the Earth so fast that it was moving faster than the speed of sound in the ground. What does that mean? If I, throw a snowball at my friend and I miss and it hits the snow is pushed out of the way of the snowball, because the first piece of snow touches the next piece of snow, touches the next piece of snow, and pushes it away. And what is the speed at which one atom pushes the next atom, pushes the next atom? The speed of sound. But what happens if a chunk of iron hits the ground so fast that it is moving faster than it can move the stuff out of its way? What happens is it can't move. Because that stuff can't get out of its way, so it makes it stop. All of a sudden, 1/2 times the mass, 50,000 tons, times the velocity, about 70 meters per second, squared, 70 kilometers per second squared. That is a really, 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 really big number representing its kinetic energy, 1/2 mass times velocity squared, which suddenly is turned into heat energy, because that's the only thing it can do, which makes it as hot as a nuclear explosion. And therefore it leaves behind a round crater, because energy is a scalar, not a vector, those of you who've done science. That's why craters are round. And that's what happened. They estimate that, 50 miles away from where this impact occurred, there were winds so strong, they were stronger than a hurricane's winds, would have knocked everything down. Enormously destructive. And it happened here on Earth. And that's just a dinky guy. It killed a few animals nearby. It didn't end all the dinosaurs. And we are in a universe where these things hit us all the time. Mostly smaller than that. But there was, a chunk the size of a school bus that hit the atmosphere above a city of 1 million people called Chelyabinsk in Siberia. One of the shocks was to say, "This is a city of 1 million people I've never heard of." And it created first a flash of light when it exploded. So everybody rushed to the window to see what's that flash of light. And then the sound wave arrived and shattered the windows. And 1,000 people wound up in hospital with cuts and bruises. Nobody killed, thankfully. That's not the only place on Earth. This looks an awful lot like Mars, except for those white clouds there. The minerals are not all that different. They're formed by volcanoes, just like the stuff on Mars. Except this happens to be Mauna Kea, a mountain in Hawaii, near where we have some telescopes. These are places like the places we've seen, which is to say the places we've seen are like things we know. Earth does have some things we haven't seen elsewhere, like rivers that create a Grand Canyon. But these are things that can be found anywhere. If you say darkness will cover me and the light around me, you make night, even the darkness is not dark to you. The night is bright as the day, for darkness is as light to you. Boy, did I realize that when I was in Antarctica and it never got dark. It was you who formed my inward parts. You knit me together in my mother's womb. I praise you, for I am fearfully and wonderfully made. Wonderful are your works, that I know very well. And these are his works. Twice every 120 years, the orbit of Venus and the orbit of Earth and the orbit and the position of the sun all line up so that we can see Venus crossing in front of the sun. And there's wonderful science you can do with this, like measuring it from two different places on Earth, and from that triangulate how far away Venus is. That was first done in the 1700s. One of the people doing that was the number 2, the assistant to the Astronomer Royal, a fellow by the name of Charles Mason. who wanted to go someplace far away from England, so he got on a boat. And he brought a surveyor with him, so he would know exactly where he was to help make the measurements. The surveyor's name was Jeremiah Dixon. On the way back, they did a little bit of surveying in the east coast of the US, the Mason-Dixon line. Captain Cook was on the other side of the world to look at the transit of Venus and discovered a few other interesting things while he was there. A quarter of all the observatories in Europe measuring the transit of Venus were run by Jesuit priests. But of course, we all know that after Galileo, the Catholic Church stopped doing any kind of science. Right. This image was taken from Castel Gandolfo, from our headquarters. This was the first one, the 2004 one. And we had a wonderful fellow from Boston who's a tremendous amateur astronomy photographer who came out with some great equipment. And he took this image, and he took that image with the little solar flare through a solar filter. If Venus were the size of the moon to our naked eye, then it would have been an eclipse. But Venus is a little bit smaller. He was there with his family. His wife was there, and we went out to dinner in one of these lovely restaurants that overlooks Lake Albano. And her stepfather joined us, who was the same age as my dad. And it was summertime, so he had a short sleeve shirt on and a number tattooed on his arm. This is also the universe we live in. We've actually landed on Venus. The Russians put spacecraft on Venus and sent back images, something that nobody else has done. It's so hot and so dense that the spacecraft only lasted about 15 or 20 minutes before they gave in to the conditions. And the air was so thick that the images were all distorted. The air itself acted like a lens. But 20 years later, everybody's got Photoshop. Suddenly, amateurs were able to take those pictures and unbend them and give them a sense of what it is that the surface of Venus actually looks like. And the sky is yellow not because it's got dust in the air, it's got sulfuric acid in the air. That's what those clouds are. When I was a kid, I read science fiction books. And they told me that Mercury always kept the same face to the sun, just like the moon keeps the same face to the earth. And it was only in the 1960s that a professor at MIT, who I wound up working with eventually, bounced some radar waves off it and found out that wasn't true. That it rotates in such a funny way that every time Schiaparelli looked at Venus, he was seeing the same side. But it was just a strobe effect. That the times he couldn't see Venus is when it was spinning in a way that would have proved him wrong. We also knew Venus was covered with clouds. It was Mercury, I meant. We also know Venus was covered with clouds. So obviously there must be a jungle underneath it. Well, no, it's not a jungle. Sulfuric acid clouds. 800 degrees at the surface. Is that 800 Fahrenheit or 800 Kelvin or 800 Celsius? It doesn't matter. It's really hot. It was a big deal at the time that Chris studies when people finally understood that the Earth was a planet. It's taken us a much longer time to appreciate that Earth is a planet, but most planets are not like Earth. It was a big deal to realize that the sun is a star, but much longer before we realized that most stars are not suns. It's only the end of the 19th century that was it Agnes Clark, is that her name? Agnes Clark wrote a wonderful book. She was sort of the Neil Tyson of her era, science popularizer, except actually very religious, good Catholic. And she pointed out something that most of us still don't appreciate. Of the 100 stars closest to our sun, 80 of them are so faint you can't see them with the naked eye. Most stars are smaller and fainter than our sun. Of the 20 brightest stars, the vast majority of them are really far away. They just happen to be enormous and enormously bright. So here's Venus, not at all like, oh, just a jungle on Earth. And yet, it's got rocks that have, aluminum and plagioclase. It's a place. Mars has moons, but it doesn't have eclipses, because the moons are way too small. They're little lumps, only about, 10 kilometers across or so. And they're quite irregular. Where did they come from? Well, as a student, I learned what any scientist and planetary scientist in America will tell you, that these are probably bits of the asteroid belt, dark asteroids that were captured by Mars. And then I went to Europe and talked to planetary scientists there who will tell you what everybody in Europe knows, that these are the accretion of basaltic rocks chipped off of Mars due to impacts. And everybody on both continents is so used to thinking that way that they've never bothered questioning, maybe they're wrong. It's only in the last 10 years we've started having meetings together and realized, wait, you think that? But don't you know how wrong that is? Why is it wrong? The same guy who discovered that Mercury was not spinning with the same face towards the sun, but actually spinning at 2/3 that rate, a fellow named Erwin Shapiro, guy I got to work with, he became the director of the Harvard Smithsonian Center for Astrophysics. And he would go to colloquia, and people hated him because he would sit in the front row and ask the stupid question that nobody asks that question because, in fact, I don't know how to answer that question. It was like, we've always assumed that, right? But why do we assume that? Where did that come from? Maybe I'm wrong. This was a body that I worked on as a graduate student. The paper that I wrote that is the most often cited paper, hundreds and hundreds of citations, is all about my work on connecting meteorites with this particular asteroid. I won't go into the details except to say that my most recent paper on the topic was to say that all my previous papers were wrong. Which is success. If you write a paper and nobody corrects it after 50 years, it means the paper was so boring that nobody bothered looking at it again. Sign of success is that you make your previous work obsolete. Jupiter is seen by a spacecraft, the Juno spacecraft. Each of those swirls is about the size of planet Earth. That spot is about 3 times the size of planet Earth. And it has a moon. Oh, you want to be controversial? What is the name of that moon? Io? Io? We can argue about that back and forth. The one thing we will all agree is that the radio announcer who said, Jupiter's moon 10 has been discovered. But the cool thing about this picture, we knew by then it was there. You look at Io, or Io. You see that little dot of light above it? That is the plume of a volcano sticking up into the sunlight because it is covered with volcanoes. And we can even see close up the hot lava coming out of the volcano. What is that stuff? The yellow stuff? Hey, I knew that from my chemistry set when I was a kid. It's sulfur. sulfur and sulfur dioxide. Like nothing you would see on Earth. Except we do have sulfur in all of our volcanoes. Ironically, the Japanese word for sulfur is Iwo, not Io. And so Iwo Jima was, a land of an island full of sulfur because it had volcanoes. And there's a view of Saturn different from you'd see from Earth because we're looking down on the rings. And the rings look a little odd because when we see the rings from Earth, what we're seeing is light hitting a chunk of ice and reflecting the light back at us. But what happens if the thing that the light hits is smaller than the wavelength of the light? Well, you've seen that every time you've gone into a room and there's a beam of light and dust in the air, and you see the light, the dust scattering the light sideways. The light you're seeing here is the light scattered sideways by dust in the rings of Saturn. And it has its moons, though interestingly, those moons are not the right size to give Saturn eclipses either. In fact, the only planet-moon system in the solar system that can give you glorious eclipses is ours. Titan is an interesting place. It's much bigger than our moon. It's about comparable to the size of planet Mercury, but it has an atmosphere of nitrogen twice as thick as the atmosphere we have. And when you land there, you can see, this was the lander that the Europeans sent, you can see ponds of liquid methane and clouds of methane raining out of the sky. When I was in Arizona and a fellow from the European Space Agency was giving a talk at the Lunar Lab in Arizona, and he was describing the measurements they came up with, and they said, according to our calculations, there would be clouds that would form droplets of rain, but as the droplets fall, they would evaporate faster than they fell so that they'd never actually reach the ground. Isn't that astonishing? And everybody in Arizona is going, we've got a word for that. Happens here all the time. Expecting the other planets to be like the planet we know. The surface actually is covered with boulders, but the boulders are made of ice. And the surface is soft, and because they're Europeans and they wanted a poetic way of giving you a sense of what the surface is like, it's not hard, it's not rigid. According to the French scientists, that flat surface has the consistency of creme brulee. There is a moon where half of the side is covered with black dirt. These are movies made of a number of still images glued together in the computer to give you a sense of what the surface of this odd moon Iapetus is really like. And then there's the moon that's full of water, and the water is leaking out of cracks in the southern hemisphere. Be praised, my Lord, through sister water, useful and humble and precious and pure. And another moon that looks like the more volatile ices have been evaporated away, leaving this very, very fluffy-looking surface. So you remember, I said the light that gets not reflected backwards but shines towards us is dust. Can you see the thin ring of dust, which actually is probably made out of the droplets of water that came from that last moon because it's located where that moon is located? The rings that we're seeing are the dusty parts shining the light towards us. The sun is, of course, on the other side of Saturn. And you might not be able to see it, so I'll help out. Right in there is a little dot of light. Wave, that's us. That's planet Earth.
Is it Pioneer?
This was the Cassini mission. Pioneer didn't have good enough cameras. Couldn't have taken a picture this good. Actually, don't get me started about the cameras in Pioneer. It's astonishing what they were able to do with what they had. Be praised, my Lord, through our sister, Mother Earth. My frame was not hidden from you when I was being made in secret, intricately woven in the depths of the earth. Your eyes beheld my unformed substance. In your book were written all the days that were formed for me. None of them has yet existed. I try to count them. They're more than the sand. I come to an end, and I'm still with you. How weighty to me are your thoughts, O God. How vast the sum of them. Be praised, my Lord, through the stars. In the heavens you've made them bright and precious and beautiful. And galaxies of stars. And galaxies orbiting galaxies. And galaxies passing through galaxies and having stars ripped off them so that they leave a trail of stars behind them. Stars that die and leave behind these rings of light. Stars that emit light so that as the light moves away from the star, we can see the gas around the star as the pulse of light flies through it. So it's not gas which is moving out, it's light which is moving out in this image. Stars being formed, like at the tip of the ear of the unicorn here. Stars being formed in the Carina Nebula. Stars being formed in an open cluster of hundreds of stars, where one or two of them are so big that they've evolved so quickly that they've already turned into red giants. And then our own sun. Be praised, my Lord, through brother fire, through whom you brighten the night, beautiful and cheerful, powerful and strong.
Doesn't all of this just make us feel smaller and more insignificant and destroy the thought that God just made me and just made you?
Well, I think it can only do so if we have the wrong idea of God. The problem is we never make God big enough. And that's true of us, it's true of people who professionally think about God. Some theologians don't make God big enough. God is big enough to make everything important. We're not. We have to, I pay attention to you now, I can't pay attention to other people. We're limited. God's not. God can make everything in the universe important. And that's what God does, because God made it and God found everything good.
And so at the end of the day, I think that's the lesson we get out of doing astronomy. We get a sense of how big God is, how amazing God is, in a way that if we just knew God intimately, we might not get. Reminds me of something that happened to me about 10 years ago. I was on the internet looking for something totally different, as usually happens, and I stumbled across a column written by a woman in England who writes, she's a gardenist. She writes the gardening column for The Independent. Her name's Emma Thompson. And instead of writing about gardens that week, she wrote about her childhood. And when she was a little girl, she loved her daddy. Daddy loved her. They had a wonderful relationship, like you would hope every father and daughter might have. The one problem was he was away from home a lot. But when he got home, he was away for work. When he got home, it was a celebration. And, just, you can imagine how much she thought of her dad. To her mind, Dad was a rock star. What can you say? When she was about 11, she discovered that her father, Pete Townsend, really was a rock star. The lead guitarist for The Who, that's why he was away all the time. We're in the same situation. The God that we have come to know so intimately through our prayer that we call our Father is also the rock star who made this universe and set things up to the glories that we hope we'll be able to see on Monday. And to remember our place in that universe. The essence of pantheism was that nature was our mother, but the main point of Christianity is that nature is not our mother, nature is our sister. Even St. Francis in the Laudato Si refers to our sister, Mother Earth. Nature is a solemn mother to the worshippers of Isis, to Wordsworth, to Emerson, but to St. Francis, nature is a sister and even a younger sister, a little dancing sister to be laughed at as well as loved. Thank you so much.